Stars light up our night sky with their mesmerizing glow, but the science behind their brilliance is even more fascinating. From nuclear fusion to cosmic radiation, let's explore how these celestial giants create their eternal light show. At the heart of every star, including our Sun, is an amazing process called nuclear fusion. Think of it like a cosmic pressure cooker. The star's core is incredibly hot and dense, squeezing hydrogen atoms together so tightly that they combine to form helium. This fusion releases massive amounts of energy in the form of light and heat. The temperature at a star's core is about 27 million degrees Fahrenheit. That's way hotter than any oven you'll find on Earth. Every second, our Sun fuses about 600 million tons of hydrogen into helium, converting some of that mass into pure energy. This energy slowly makes its way to the star's surface, creating the bright light we see in our night sky. Let's take a closer look at how stars work as cosmic kitchens. Inside a star, hydrogen atoms act like ingredients in a recipe. The extreme heat and pressure at the core push these atoms so close together that they merge into helium. It's like cooking at temperatures millions of times hotter than your kitchen stove. This process is happening right now in our Sun, where 4 hydrogen atoms combine to create 1 helium atom. The leftover mass doesn't go to waste. It transforms into pure energy. This is what Einstein meant in his famous EMC2 equation. Every time this cosmic cooking happens, the star releases energy as light and heat, feeding the universe with the building blocks of life. Have you ever noticed that stars twinkle in different colors? This isn't just pretty, it's actually a cosmic temperature gauge. Stars shine in various colors based on how hot they are, just like how a flame changes from red to blue as it gets hotter. The coolest stars glow in red at around 3000 degrees Fahrenheit. That's still way hotter than your oven. Medium temperature stars like our Sun shine in yellow or white at about 10,000 degrees. The hottest stars burn bright blue, reaching a mind-boggling 40,000 degrees Fahrenheit. When you look up at the night sky, you're seeing a rainbow of stellar temperatures, each color telling us exactly how hot that distant star is burning. Let's zoom in on our closest stellar neighbor, the Sun. This massive ball of glowing gas is so huge that you could fit over 1 million Earths inside it. The Sun's surface is a constant dance of activity, with giant loops of hot gas called solar flares shooting into space. These flares are like massive bursts of energy. Imagine 1 million nuclear bombs going off at once. The Sun's outer layer, called the photosphere, is what we see glowing at about 10,000 degrees Fahrenheit. Below this surface lies the chromosphere, a pink layer that's actually hotter than the surface. Finally, there's the corona, a super-hot outer atmosphere that's only visible during solar eclipses. Despite being 93 million miles away, the Sun's energy reaches Earth in just 8 minutes, powering nearly all life on our planet. The size of a star plays a huge role in how bright it shines and how long it lives. Think of stars like cosmic light bulbs. Bigger stars burn much brighter, but use up their fuel faster. A massive star might be 100 times bigger than our Sun and shine 10,000 times brighter, but it only lives for a few million years. Compare that to smaller stars, which are more like energy-saving bulbs. They burn their fuel slowly and steadily, sometimes lasting billions of years. Our Sun is actually a medium-sized star, and it's already been shining for about 4.6 billion years. It still has enough hydrogen fuel to keep glowing for another 5 billion years. The smallest stars, called red dwarfs, are truly the marathon runners of the universe. They can keep shining for over 100 billion years. When we talk about stars, we can't ignore the incredible force that makes them shine. Gravity. Imagine squeezing a giant ball of gas with the strength of 1 million Earths. That's what's happening inside every star. This massive pressure from gravity pushes the star's core to extreme temperatures and densities. The more massive a star is, the stronger its gravity becomes, creating even more pressure and heat at its center. This is why big stars burn so much brighter than smaller ones. The balance between gravity pushing inward and the outward pressure from nuclear fusion keeps stars stable for millions or billions of years. It's like a cosmic tug-of-war that keeps these giant balls of gas from either exploding or collapsing. The journey of starlight from a star's core to space is like an epic obstacle course that can take thousands of years. When energy is created in the core through fusion, it doesn't zoom straight out. Instead, it bounces around like a pinball. The light particles, called photons, bump into countless atoms as they try to escape. Each collision sends them in a new random direction. What starts as high-energy gamma rays gradually loses energy through these collisions, eventually becoming the visible light we see. By the time these photons reach the star's surface, they've traveled millions of miles in a zigzag pattern. While light from the surface reaches Earth in minutes, the energy's initial journey from core to surface can take up to 100,000 years. Stars don't stay the same forever. They go through different life stages, just like living things. They start as giant clouds of gas and dust that slowly come together due to gravity. As the cloud gets smaller and denser, it heats up until it's hot enough to start nuclear fusion. This is when a star is officially born. During most of its life, a star burns steadily, fusing hydrogen into helium. But when it runs low on hydrogen fuel, things get interesting. Bigger stars expand into red giants, while the biggest ones end their lives in spectacular explosions called supernovas. Smaller stars, like our Sun, will eventually turn into white dwarfs, small, dense stars that slowly cool down over billions of years. Stars don't just create the visible light we see, they're cosmic powerhouses pumping out all sorts of energy waves. From X-rays to radio waves, stars blast different types of radiation across space. The hottest parts of stars produce X-rays and ultraviolet radiation, the same kind that causes sunburns, but much stronger. The cooler outer regions give off infrared radiation, which we feel as heat. Stars also release radio waves that help astronomers study them from Earth. Our Sun sends out a constant stream of charged particles called the solar wind, which creates beautiful auroras when it hits Earth's magnetic field. All these different types of radiation tell us important details about a star's temperature, size, and chemical makeup. Looking into the future of stars reveals an incredible timeline of cosmic light shows. Stars like our Sun have enough hydrogen fuel to keep shining for billions of years. Our own star still has about 5 billion years of bright days ahead. The smallest stars, called red dwarfs, are the real champions of longevity. They burn their fuel so slowly that they could keep glowing for over 100 billion years. But the biggest stars in our galaxy are like bright fireworks. They shine super bright but burn out quickly in just a few million years. Eventually, all stars will use up their fuel, but don't worry. New stars are being born all the time in giant gas clouds throughout space, ensuring the universe stays bright for countless generations to come. Thanks for joining us on this stellar journey through the science of starlight. If you enjoyed learning about these cosmic light shows, hit that like button and subscribe for more space science. Share with friends who love exploring the universe.